everyone, today we are going to understand conservation of momentum. To understand what is conservation of momentum, first we will understand what is momentum. To understand momentum, we will take two cases. In first case, we will take a car and a truck. Let's suppose both are moving with a velocity that is v. Now, what do you think? If you stand in front of both the car and truck, what do you think? Which will give you a greater impact on you? Your answer will be the truck, because the truck has more mass. So from this we can say that if an object has more mass, it will give us more impact. Now we will take another situation. In this situation, we will take two cars of the same mass, that is m and m, but both are moving with different velocity. First one is moving with velocity v and second one is moving with the velocity 2v. Now again you are standing in front of them. What do you think? Which will give the more impact? The answer is car number 2, because it has more velocity, that is 2v. So velocity is also dependent on the impact of force. So now the momentum is nothing but the impact of force and the quantity of force. When we say that mass is directly proportional to momentum, and similarly velocity is also directly proportional to momentum. Now when we will combine these two equations, we will see that momentum is directly proportional to mass multiplied by velocity. When we will remove the proportionality sign and put a equal to, we will add a constant, that is k, mass into velocity, and here is momentum. Now let's put k as 1, then the final formula of momentum will be calculated as m into v. Momentum is denoted by p. Now we can define momentum as the impact of force and the quantity of force. Now the impact of force is also dependent on mass and the velocity of object. If the mass is more, then the impact will more, and similarly if the velocity will more, the impact will also more. Now momentum is a vector quantity. It has also direction with it, because the velocity is also a vector quantity. Now we will find out the SI unit of momentum. SI unit of momentum can be found from its formula, because the momentum SI unit is derived unit. So what we will know that the SI unit of mass is kg and the SI unit of velocity is meter per second. So when we will multiply kg and meter per second, it will give us kg meter per second. So the SI unit of momentum is kg meter per second. So this is all about the momentum. That momentum is the impact of force and the quantity of motion. Now moving to next is our conservation of momentum. When we study about conservation of momentum, we study about the collision of two bodies. It states that if two bodies collide with each other, the momentum before and after the collision is always the same. So let's suppose this is an mass m and this is m1. Let's make this again. Let's suppose this is a object of mass m1 and this is object of mass m2. m1 is moving with a velocity, initial velocity, that is u, and m2 is moving with a velocity, that is, this is u1 and this is u2. Now in the between case, m1 and m2 collide with each other. What happened after that? That m1 starts moving with a v velocity and m2 start moving with a v1 velocity and v2 velocity. Now here we can see that there is an interaction between the two objects m1 and m2. From here we can say that m2 is applying force on m1. So this is the force of 1 due to 2, and this is the force of force of 2 due to 1. So let's write this. Let F is equals to 1 2, and this will be F is equals to 2 1. Now from here we can see this is applying force in the positive direction, and this is applying force in negative direction. So we will put a negative sign in one of them. So let's put it here. Now as we know that the formula of force is equals to mass multiplied by acceleration. So for here we can write that m1 a1 is equals to minus m2 and a2. Now here we can see acceleration can also be changed. Acceleration is equals to v minus u upon t. So we will write it as m1 v1 minus u1 upon t1 and minus m2 v2 minus u2 upon t2. Here we have removed the a1 and a2 by using the formula of acceleration, that is v minus u upon t. Now as we can see, there is the law of third equation. There is a third law of motion, Newton's third law of motion applying here. That first object is applying force on the other object, and the other object is applying the same and equal force on the other object. So we can say that the time interval of both the forces are equal, because there is no delay in the third law of motion. So from here we can cancel t1 and t2. Now here we can see m1 v1 minus m1 u1 is equals to minus m2 v2 and plus m2 u2. Here we will rearrange it. Then we can say minus m2 v2 will go here. m1 v1 plus m2 v2 is equals to m1 u1 plus m2 u2. LHS is equals to RHS and RHS is equals to LHS. So we will move it here and here. So it will be m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. So this is the formula of finding conservation of momentum. In this we can see m1 u1 and m2 u2 means the initial momentum of the object, mass into velocity, mass into initial velocity, and the second is mass into initial velocity of the second body, and is equals to the mass into velocity of first body, final velocity, and mass into final velocity of the second body. So the sum of both the bodies of momentum is always equal to each other. From here we can say that the conservation of momentum is proved. Now this means that we can also write it as initial momentum is equals to the final momentum. So we can say that P initial is equals to P final. Initial momentum is equals to final momentum. Now let's discuss something about conservation of momentum again. So what we were saying that conservation of momentum is about the collision of two bodies. So let's take 3 examples and understand it better. These are the daily life examples of accident. So in the first case, we will take a car. So let's suppose this is a car and it has some mass and it is moving with a velocity. Here is a man standing. Now the car hits the man. What do you think? What will happen to the man? The man will go flying away. Why? Because the mass of the man is very less than the mass of the car. The car's mass is very high than the mass of the man. So to conserve the momentum, that is P is equals to m into v, when the mass of the object is very low, it has to conserve the momentum and increase its velocity. So hence the man's velocity is increased very high and hence the man goes on flying. Now let's take the another example. In this we will take a truck here and a car. The truck is moving with a velocity and it is also moving with a velocity. Now what happened? The truck moved fast and hit the car. Now in this case, the velocity of the car will not move that much of in the first case of that man, because the mass of the car is in good amount. That is, mass will be 100 kilogram or 500 kilogram. Hence, momentum is equals to mass into velocity. Here, the mass of the object is not as less as the man. Hence, the car's velocity will be increased very little. Okay, and the velocity of the truck will be slowed a little to conserve the momentum. Now we will take another case, that is, we will take two trucks here. Two trucks of the same mass, and the first truck is moving with higher velocity and it hits the second car. What will happen that the truck's velocity will not move that much. It will move a very little distance, but in the car 2 that hit the car 1 will move backward by hitting it. This is because to make the momentum conserve. When the velocity will get negative, the momentum will get decreased. Hence, the momentum will be conserved. So these are the cases in which we can see that conservation of momentum is applicable. So in the whole universe, the conservation of momentum is always applicable. Whenever two bodies are colliding, there is conservation of momentum applicable. Thank you.